Our next lesson is going to be on solving logarithmic equations. So here are the steps we're going to take to solve equations. The first thing we're going to do is rewrite the equation with one term on each side. And then we're going to take the exponential function of the same base to undo the log function because they're inverses. Then we're going to solve it like any other equation, and the last thing we need to do is check for extraneous solutions because you cannot take the log of a negative number. Okay, so let's take a look at our first problem. For number 1, first thing we need to do is make sure we only have one term on each side, which we do. What we want, though, is to have just the log with nothing in front of it. So you see how there's a 2 right here. The first thing I'm going to do is take this 2 using our log rules and move it to x to become the exponent. So now I have log of x squared equals log of 9. So now I have one term on each side. I'm going to undo the log by taking the exponential function of the same base. So what is the base if there is no number next to my log? This is like it's a base 10, right? Invisible 10 written there. So to undo it, what I'm going to do is raise this entire thing to the power of 10. So I'm making this my exponent, 10 to the power of this, 10 to the power of this, because these cancel out, and this leaves me with x squared equals 9. And now this is a problem I know how to solve. To get x by itself, I got to undo the squared by taking the square root. So I know that x is going to be equal to, when I take the square root, it could either be positive or negative 3. So right now I have two answers. I either have a positive 3 or a negative 3. The last thing I need to do is check for any extraneous solutions. So extraneous solutions are ones that actually are not solutions. Because, for example, if I plug this back into my equation, I know I can't take the log of a negative number. So if I put 3 back into my equation here for x, that's positive, so I know that this is possible. But if I plug negative 3 back into this equation, it would be log of negative 3. And that would not be possible, so this is an extraneous solution. So that's actually not one of my solutions. Okay, let's look at number 2. So for number 2, I have a 3 log base 3, 4x minus 7. These can cancel out because this is not an exponent. It's got to look like 10 to the power of something. So I need to get rid of this 3. The way I'm going to get rid of it is like any other equation. See what's happening between the 3 and the log? They're being multiplied. So I'm just going to divide this whole thing by 3. So just like any other equation, I'm going to start on the outside and work in. So these cancel out. This leaves me with log base 3, 4x minus 7 equals 6 divided by 3, which is 2. Okay, so now I have one term on each side. I'm now going to undo this log function. Okay, so the inverse of this log function with a base of 3 is 3 to the power of that log base 3. Make sure you want to do it to both sides. So this 3 and this log base 3 cancel out. But unlike our last problem, these actually don't cancel out, right? 3 to the second power, this actually gives you a number. So I'm going to bring this down. 3 squared is 9. What's left over here is 4x minus 7. So be careful, this is the stuff that most people mess up on. They just forget to do 3 to the second power and just accidentally bring down just the 2. This now we can solve like any other problem, so we're getting x by itself, starting with the outside. So get rid of the minus 7. 4x equals 16, get rid of the 4. Right now they're being multiplied, so we divide. We get x is equal to 16 divided by 4, which is 4. And if you plug 4 back into your equation, so now we're checking for extraneous solutions. 4 times 4 minus 7, 16 minus 7, that's going to be positive. So this is an answer for my problem. Okay, let's look at number 3. So for this one, notice how on the left side here, we have 2 logs. So we have to combine this into just one log using our log rules that we learned last week. So right now, if these two are being added, and I'm trying to combine them into one log, now they're going to be multiplied. Alright, so addition turns into multiplication. And now that I have one log, and this side's also just one term, Now I can undo my log base 4. So to get rid of log base 4, I'm going to raise everything to the base of 4. So 4 to the power of, 4 to the power of. These cancel out. On this side, 4 to the 1 is just 4. Over here I have x plus 3 times 2 minus x. So to solve this, what I'm going to do now is distribute. So I have x times 2, which is 2x, x times negative x, which is negative x squared, 3 times 2, which is positive 6, and then 3 times negative x, which is negative 3x. Now let's combine like terms. So I have a negative x squared, that stays there. I have a 2x and a negative 3x. So when I add together 2 plus negative 3, it gives me negative 1x. Then I have this plus 6 equals 4. To solve this, it's clearly a quadratic. What I need to do is get everything onto one side, so it's equal to 0. So I'm going to move, because this is a negative x, I want my negative x squared to be positive, so I'm going to move everything on this side over to the other side. So I'm going to plus x squared plus 1x minus 6. Whatever I do to this side, I'm going to do to this side as well. So plus x squared plus 1x minus 6 is going to go from the 4. So this is now 0 equals positive x squared plus 1x. 4 minus 6 gives me negative 2. And this is the equation that I'm going to solve. So this is x box. Well, it multiplies to give me negative 2, adds to give me 1. 2 and 1 with it's going to be a negative 1. So 0 equals, I have x plus 2, x minus 1. And when I set these equal to 0 and solve, my two answers are x is equal to negative 2 and x is equal to positive 1. Now let's check for our extraneous solution. So if my answer is negative 2, and I plug negative 2 here, negative 2 plus 3, that gives me a positive number. 2 minus negative 2 also gives me a positive number. So this is a correct answer. So even though it's negative, it's not extraneous, because when I plug it in, both of these numbers are going to be positive. When I plug in 1, so 1 plus 3, that is going to be positive. 2 minus 1, that's also going to be positive. So these two are both answers for number 3. Okay, let's look at number 4. So same thing, these are two separate logs. We need to combine them into one log. So since it's being added, we know this means multiplication. So we're multiplying x times x minus 6. And this is equal to 3. Now that I have one log, I can undo this log. It's a base of 3, so this is going to be 3 to the power of, 3 to the power of. These cancel out. This leaves me with x minus 6 equals 3 to the power of 3, which is 27. Again, I'm going to distribute, so I have x squared minus 6x equals 27. I need everything onto one side because this is a quadratic. I'm going to move it onto this side this time because I want to keep this x squared positive. So I'm going to subtract 27 from both sides. I have x squared minus 6x minus 27 equals 0. And now I can x box. So what multiplies to give me negative 27 adds to give me negative 6. So I have 1 and 27, 3 and 9. 3 and 9. I want this to be negative 6, so it should be negative 9. So this leaves me with x minus 9, x plus 3 equals 0. And when I set them both equal to 0 to solve, I get x is equal to 9, and x is equal to negative 3. So let's check and make sure that these are not extraneous. So when I plug in 9, this will be positive. If I plug in 9 minus 6, that gives me 3, which is also positive. So this is an answer. When I plug in negative 3, so this is taking the log of a negative number, so this one is extraneous because that's not possible. So my answer for number 4 is 9. Okay, let's go on to our next problem. For number 5, we have 2 log base 3 of x minus 4 minus log base 3 of 9 equals 4. So our first step for this one, you should notice this is a log that we can actually take. So this is something back from our first unit here. This is asking us, our base is 3, so 3 to what power equals 9. And 3 squared is the same thing as 9. So we know that the exponent this is asking for, this is just 2. Right, so we can rewrite this entire equation knowing that log base 3 of 9 is just 2. So if you have something you can simplify to a number, you should do that. And now we're solving this again, so we're trying to get log by itself, so we're trying to get just one term. So I need to get rid of this minus 2 and this 2. I always start with the outside when we're undoing, so I'm going to add 2 to get rid of this. 4 plus 2 is 6. And now I need to get rid of this 2 in the front. I'm going to divide by 2. Gives me 3. And now that I have the log by itself, I can undo the log by raising it to the power of 3. So I have x minus 4 equals 3 to the power of 3, which is 27. And now we're just solving for x. So plus 4, x is equal to 31. Okay, so our next problem looks a little bit trickier, but it's the same steps we have been doing. So right now you can see the log is already by itself. We need to undo this log by raising it to the base. So look at what the base is. In this case, our base is 1/2. So we are going to raise both of these to the 1/2 so that I can undo this log. So this leaves me with 4x 3 over 2. Over here I have 1/2 to the negative 3. And I can actually do 1/2 to the negative 3. So first of all, it's a negative number. So a negative number in my exponent means I'm going to flip it. So this is actually the same thing as 2 to the power of 3. And what is 2 to the power of 3? It's 8. Right, so this is 4x to the 3 over 2 equals 8. And we've done problems like this before when we're trying to undo this 3 over 2. How do we get rid of this exponent 3 over 2? We're going to raise it to the reciprocal, 2/3. Because these are now cancel each other out to give you 4x. And over here, this 8 to the power of 2/3. The 3 on the bottom is actually a root. So really what we're doing is cube root of 8 squared. So cube root of 8 is what to the 3rd power gives you 8. We already know it's going to be 2. And then 2 squared is just 4. And now we can solve for x. So divide by 4, we have x is equal to 1. And if you plug 1 in, it's going to be positive, so this is not an extraneous solution. Here is my final answer.